Hello everyone, hope you're doing and welcome back to my channel. Today we are at day 20 of the January daily lead code challenge and we again have a medium question in front of us. Yesterday and day before yesterday we had some hard questions. They were some really good questions. They were, I can say, fang level interview questions. So if you have not done that question, please go and check out day 19 and day 18 videos. They are really good questions. They will change your perspective you have for hard level question in lead code. Okay? So go and check that out. And again, coming to today's question, it's going to be a medium level question. And before starting that, a big congratulations to all of you who have completed till now, because like see, today we are going to complete the 20th question, which is we are going to complete two-thirds of the January daily LeetCode challenge today. So if you have been consistent till this point, a big congratulations to all of you. Okay, so this is something that I wanted to say before starting the question. And now coming to this question, see, this question is going to be very easy. Okay, this just means that you know what is a what is mapping, how to hash the values. If you know about a hash map, this question is going to be very easy for you. Okay, see, I can say like this kind of question you can expect in a interview of, let me tell you, like TCS or Infosys or like those kind of companies, or maybe on a round one of a big company you can expect this kind of questions. Because see, here what will matter is how good you are, or like how quick you are in terms of your response and in terms of understanding. Okay, this is not a very hard question. It is just to check whether you are okay, very like decent in terms of coding or not. Okay, this is not something great. If you are able to solve it, you will not be considered a great, but still this is just to, I can say, like a tip of the iceberg. Okay, as simple as that. So now coming to this question, it is 2661, first completely painted row or column. Okay, so let us now see what is it. So before going to the question, I will try to explain what is happening in terms of diagram, because the diagrams here are very good. So let us quickly see the diagrams. Okay, first of all, we are given a matrix. So whenever you have a matrix, you will always know that there are going to be two sides, m and n. Okay, so total elements in the matrix are going to be m cross n, that is m into n. Okay, now let me tell you one more thing. The elements, that is, see, we have array also. So the number of elements in the array and the number of elements in the matrix are going to be same. And one more thing here is, we know what are the elements going to be. That is, let us say here the the total number of elements are m into n. Okay, what is m into n? M is, let us say, one dimension, n is a second dimension. So total elements in the matrix are going to be m into n. So we know that the elements in the array are going to be from 1 to m into n. Okay, that is, see, this part, it is 2 cross 2, right? So elements are going to be 1, 2, 3, and 4. Okay, till from 1 to 2 into 2. Okay, that is 1 to 4. Okay, similarly here also it is going to be 1 to 4. Okay, fine. One more thing is, all the elements in this are going to be unique. Okay, let me show the constraints itself first. See this part, m and n are going to be the dimensions. Then if you see m into n, so the matrix is going to have m into n elements. Similarly, the array is also going to have m into n elements. M and n are going to be in the range of 10 power 5. That is, each dimension of the matrix is going to be in the range of 10 power 5. Okay, and they are saying the overall. Okay, even the overall number of elements is going to be in the range of 10 power 5, right? One more thing is, see this part, this is going to be the most important part. This will basically like shape the approach that we are going to decide. Okay, this will like test your understanding of how much you know a particular topic. Okay, so these are going to be your hints for that topic. So they are trying to tell you that all the elements in the area are going to be unique and all the elements in the matrix are going to be unique. Okay, see, the idea here is we are going to use the hash map approach here. So if see, hash map means for a key there is going to be value. Okay, if the key is going to repeat, that is, there are going to be multiple values for a key, then you can see like the hash map is not a good approach for that. Okay, here they are telling you that all the things are going to be unique. For that reason, it's very efficient to have a hash map approach for this. Okay, now let's see what we can do. So what you have to do is, see this part. For example, here if it's one is mentioned here, that means one will be there somewhere in the matrix also. Okay, similarly for all the elements, so all the elements here and all the elements in this matrix are the same. Okay, be very clear with that. So what they're saying is, you have to start from left to right in the array. Okay, that is, from index 0 you have to go to index m into n minus 1. Okay, so there are going to m into n elements, so the last element will be m into n minus 1. You have to go from 0 till the last element. So see, here the first element is 1. That means go to the matrix, wherever 1 is present, go to that coordinate and paint that particular coordinate. Okay, so this is painted. Similarly, I came to 3, I am going to paint the coordinate which is containing 3. Okay, similarly went to 4, I painted the coordinate which is containing 4. Now the thing is, whichever is the first index where you have at least a full row painted or a full column painted, that is going to be your answer. So if you see here, when I painted the 4, okay, 4 is present in this particular index 0 comma 1. So once I painted 4, I got to know that one row or one column is done. Okay, in this case both a row and column are done, but in some other case what will happen is, either a row will be done or a column will be done. Okay, there you have to stop, because the question is that only whenever a single row or a single column, remember, or I am saying a single row or a single column is done, in that case that is going to be your answer. So you have to return the index of this. Okay, so 4 is at present as index 2. Okay, 4 is present at index 2, so 2 is going to be your answer. Okay, so that is the question. So let us now see the question. You are given a zero index integer array ARR and m cross n matrix. Okay, mat. array and matrix both contain all the integers in the range 1 comma m into n. Okay, so all the elements including both of these. Okay, including 1 and including m into n. Okay, now go through each index I in arr starting from index 0 and paint the cell in matrix containing the integer arr of I. That is, once you see 1, go to the matrix and wherever 1 is present, paint that. Okay, as simple as that. So what you have to do next, you return the smallest index I at which either a row or a column will be completely painted in matrix. Okay, as you can see, once I see in this case, okay, let me tell you the example I'm going to do that, because that will be making the topic very clear to you. See, first I painted 2. Okay, see the image, first image 2 is painted, then 8 is painted, then 7 is painted, and then 4 is painted. The second you paint 4, you get to know that one column is done now. Okay, your column, one column is done now. Since a single column or a row is done, what you have to do, you have to return this index as your answer. So what is this index? The index for 4 is going to be 3, so 3 is going to be your answer. Okay, as simple as that. So you can go through these examples again. I can give the link of this question in the description. Check that out. So this is the question. And now coming to how you're going to try that. Okay, if this question comes in an interview, what you have to do? First of all, let us discuss what is the brute force approach going to be. Okay, brute force is going to be very, very simple. See, as usual, we have to do the simulation. So what is the simulation? See, you'll have to go through each element of this in left to right order. Whenever you see element, you'll have to go to the matrix and search all the elements in the matrix where it appears. Once you found the element, go and mark that element here. Okay, as simple as that. So this is going to be a brute force approach. So brute force, what you do? So this is going to take you m into n time passing through this, and when you are passing through this at each index, you'll have to again do a m into n search. Okay, to get to know where the index is going to be. Okay, where this element is going to be, to get the coordinates of that element. So this is going to be a m into n square approach. Okay, fine. So this is not efficient one. So what we can do, so like try to see what can help us. See, when I'm at a 1, I need to know where, let is, what are the coordinates of 1 going to be in the matrix. Similarly, when I'm at 3, I need to know what is the coordinate of 3 going to be in the matrix. So for that reason, I can use hash map. Since all the elements in this are going to be unique, similarly all the elements in this are also going to be unique. What we can do is we can think of hash map. So what the hash map will do, hash map will do that whenever, see, the key is going to be the element here, the value is going to be the coordinate of that element. Okay, for example, let us say I am talking about 4. So when I insert 4, that is when I ask for 4, it is going to give me the value of its coordinate. Okay, as simple as that. So that is how we are going to use the hash map. So let me show you how we are doing it. Okay, one more thing that again I will emphasize, that remember, though it is not looking like that, but all the elements in this matrix and in this array are same. That is, both of them are going to have m into an element. So it doesn't matter which one you are going to hash. Okay, whether you hash the coordinates in the matrix or you hash the coordinates in the array, it doesn't matter, because both of them, see, all the keys are going to be the same. That is m into n keys we have to hash. Okay, so either you hash the array or the matrix, it doesn't matter. Okay, you can try both the ways, but again, it's up to you. Okay, I am going to hash the metric indexes. Okay, as simple as that. So let me show you my solution first. So see this part of as simple as that. Like first, we are capturing the dimensions, that n is going to be number of rows, m is going to tell me how many columns are there. Okay, now I am going to create a mapping. Okay, this is called a dictionary in Python. You can also call it as a mapping. This is basically like containing all the key value pairs. Okay, so how many keys we are going to have? The idea here is, for all the elements in this particular matrix, we are going to store their indexes, their coordinates as their values. Okay, so it is going to have m into n key value pairs. Okay, let us see how we are doing that. I am going through each element, that is, I am going through each row. In each row, I'm going through each element, and that. Okay, so this is the current element. Okay, for I comma j, this is the current element. This will be treated as a key now, and the value for that is going to be its coordinate. Okay, let me quickly show you how this looks basically. See this part. So let me show you example number 1. Yeah, so see, for 1, the for 1 is the value, key is going to be 0 comma 0. What is 0 comma 0? It's going to be its coordinate in the matrix. Okay, similarly for 4, 4 is going to be the key. What is the value going to be? Value is going to be the coordinate in the matrix. Okay, 4 is present in 0 comma 1, so its value is going to be okay, 0 comma 1. Same for 2. 2 is the key, and what is the value going to be? It is going to be 1 comma 0, because 1 comma 0 is the value. Okay, so yeah, 1 comma 0 is going to be the coordinate. So once we are done with this loop, I am now sure that I have recorded, for all the elements in the matrix, I have now recorded their coordinates. Okay, so this print statement I've already like made it, I have already commented this, but yeah, like this output is having that output of all that. Okay, but when you're submitting, you have to just ensure that you are always commenting on the print statements, right? Now comes the most important part. See, the second I am done with a single row or a single column, I should be stopping there. I have to return that as the answer. Okay, so how to do that? So that will be done using this. For that, I'm creating another mapping, or you can say another dictionary. This I'm going to call it as a row column completed dictionary. Okay, so this I'm keeping as a default dictionary. What is a default dictionary? See, between this and this, there is only one difference. The default dictionary, what will happen is, you don't have to initialize the values. The second you are inserting a key, the value of 0 will be marked on it. Okay, why value of 0? Because the value we are giving the idea, we are giving the hint that the value is going to be integer. For that reason, whenever you're going to insert a key, okay, the value is always going to be 0 by default. Okay, as simple as that, right? So what is this going to store? This will tell me that for each row, that is for, see how many rows we have and how many columns we have. For all of them, there is going to be a key in that. Okay. So if you talk about how many keys are there in total, it is going to be O of m plus n. Okay. Because m plus n keys are there. M for that is C. For each row and for each column, there is going to be key in this. Okay. That will tell me how many elements for that row, for that column we have seen till now. Okay. As simple as that. Okay. Let's see how it works. I'm going through all the elements in the array. See, array is also going to m into m elements. Okay. So see, I'm not directly taking its length. Okay. What I'm doing, whatever length I calculated for this, that itself I'm taking it here. Okay. I'm just keeping it m into n. Okay. As simple as that. I'm going through each element of this array. Okay. Now, what is the array element going to be? ARR of 5 is going to be the value of that. Okay. So for example, 1 means ARR of 5. Okay. As simple as that. ARR of 0 in that case. Okay. So I'm just using this matrix to get the coordinates of ARR of 5. Okay. ARR of 5 is the value in the array. For that, I want the coordinates in the matrix. For that, I am passing that into matrix index. Okay. Using this index, using this mapping, I can get the x and y coordinates of that. Okay. Once I got the x and y coordinates, what I can do, x will tell me which row it belongs to. That see, this element belongs to which row in the matrix. X is going to tell me that. Y is going to tell me this particular element belongs to which column. Okay. So what I can do is, for that particular key, I can increment that by 1. Okay, let me show how it works. See, if only if you see, you will be able to understand. See this part. When I'm at index 0, so what is index 0? Index 0 is basically 1. Okay, so where is 1 going to be? See, 1 is going to be in 0 comma 0 index. Okay, so it belongs to row number 0 and column number 0. Okay, so I incremented row number 0 by 1 and I incremented column number 0 by 1. Okay, so this is how the key is going to look like. Okay, R means row, 0 means the row number. Similarly, C means column, 0 means the column number. So it is column number 0, this is row number 0. Okay, let us see the next element. So when I'm index number 1, okay, what is index number 1? It is going to be 3. So what is the coordinates for 3? Coordinates for 3 is going to be 1 comma 1. Okay, so I'm going to increment C1 and R1 by 1. Okay, so C1 and R1, it got incremented by 1. Okay, as simple as that. See, that's why I use the default dictionary. So see, the default value is 0 and I'm incrementing them by 1, so it is becoming 1. Okay, as simple as that, right? Let us see the next element, 2. So what is the index number 2 element? So index number 2 element is going to be 4. Okay, so what is the coordinate for 4? 4 is having 0 comma 1. Okay, that it belongs to row number 0 and column number 1. Okay, so you have to increment R0 by 1 and C1 by 1. Okay, so we are incrementing R0 by 1. See, previously it was 1, R0 is 1, we have to increment it by 1, so it becomes 2. Okay, similarly C1, so you have to increment C1 by 1. Okay, C1 was 1 initially, now I'm incrementing it, so it becomes C1, now become 2. Okay, so now in this case, at this particular moment, what we got to know is row 0 and as well as column 1 are now done. Okay, all the elements in row 0 and similarly all the elements in column 1 are now done. So at this point, we have to return this as the answer. So we have to stop the execution and have to return this as the answer. So as you can see, this is the answer, right? So that is what we are going to do. So this x is going to tell me the row number, this y is going to tell me the column number. Okay, so row number, this particular row number, I'm using this as the key and I'm incrementing its value by 1. Similarly, y with like C and y are being concatenated, and this will tell me the key, and for this key I am incrementing the value by 1. Okay, as simple as that. Then I'm going to say this print statement is just for your purpose. Okay, let me comment it out so that, see, while you are exploring it, just use this print statements. They can help you to understand the solution better. Okay, now after incrementing both of them, that is, see, each cell belongs to a row and a column. Okay, you have to increment both of them. After that, I'm just checking. See, now, see, can you quickly tell me a single row is going to have how many elements? Now, see, a single row is going to have a number of elements. See how to approach this. See, a single row will have that many elements, which is equal to number of columns. So how many columns we are having? We are having m columns. Similarly, if you talk about C, see how many going elements are going to be there in a single column. So number of elements in a single column is going to be number of rows. So how many rows we have? We have n rows. Okay, you have to think it like that, right? So either if this is done or if this is done, if any one of them is done, then we have to return I as the answer. Okay, as simple as that. If you see, after this for loop, I have not kept any other return statements because I'm sure that there will definitely be a case where at least one row or one column is done, because if you see, the elements are repeating. Okay, the elements are fixed. Okay, the elements are fixed for both array and the matrix. The elements are fixed, so there'll definitely be a case where at least a row or a column are having all the elements weighted. Okay, so that's why after this follow, I'm not keeping any other return statement, right? So yeah, that was my approach, and as you can see, this is clearing all the test cases. And yep, you can go through the print statements. You can, like, if you have any questions, you can please let me know. Now, if you come out the time complexity, see this part. This matrix is used to store the coordinates for all the elements in the matrix. So how many elements are going to be there? There are going to be m into n elements. Okay, there are going to be m into n key value pairs now. Okay, so the space complexity for this is going to be m into n, right? So what is the other stuff that is going to contribute to the space complexity? That is going to be this. So what is this going to have? It is going to have m plus n q loop pairs. Okay, so the space complexity is going to O of m plus n. Now see this part, which is the dominating factor. Obviously, this is the dominating factor. This is not the dominating factor. So we can conclude that the space complexity is going to be O of m into n. Okay, remember this is a smaller factor. M into n is always bigger than m plus n, right? So we have to say that space complexity is going to be m into n. Okay, this will not be mentioned in the space complexity because this is already being contained in this. Okay, as simple as that, right? Remember, please learn about big O notation. If you have any doubt in what I am saying currently, you have to learn big O notation. Only then you will be understanding why I'm saying like that. Okay, as simple as that, right? Now coming to time complexity. See, one thing is clear: space complexity is going to be O of m into n, right? Now coming to time complexity is going to be very very clear. See, once we have to go through whole matrix, which is going to take O of m into n time. Similarly, we have to go through whole array once. Okay, this ARR we have to go through all of its elements once. Again, that is going to take O of m into n time. Okay, so the overall time complexity is going to be O of m into n, right? So yeah, fun. That was all for this particular video. I've explained the space and time complexity also, and yeah, this was the solution. Remember one thing: like some people will say that okay, this time I have I've stored the coordinates using the matrix. Okay, let me store the coordinates of the array. That also you can do, but remember that is not going to be efficient solution. It is going to be the same solution. Remember the elements in a matrix and the array are same. So please do not say in the interview that okay, I can improve, like I can optimize the solution by storing the coordinates of the array instead of doing the matrix. Remember, you can do that, that will also work, but that is not optimized solution. That is also going to have the same space and time complexity only, because see here the number of elements in this and the number of elements in this, okay, are the same. Okay, for that reason it is not going to be efficient solution. It is the equivalent solution but not efficient solution. So Evan, that was all for this video. And once again I will remind you, if you have not seen yesterday's video, that is day 19 and day 18, okay, of the January daily LeetCode challenge, please go and do them. They will change your perspective of how to approach a hard level question. They were a fang level interview question, so please pay respect to those questions. They can change your life. If, like, see, first of all you have to remove that fear, like okay, hard questions coming, let me not write. You have to remove that fear. I can tell you that you can do wonders after that. So please try those questions, especially it's going to be a very very good question. Okay, you will definitely appreciate yourself after you have learned the concept. Okay, you will definitely appreciate yourself. It's that kind of question. Okay, it's not something like okay, I don't know the algorithm, I don't know the data structure, I cannot do. It's not like that. It's all about imagination. If you have that imagination, that especially the day 19 question, it's all about imagination. Okay, if you can imagine it, you can do it. Okay, as simple as that. So yeah, that was all for this video. If you like my efforts, if you like my content, or if you get anything to learn from this video, like, please subscribe to the channel. See, my aim is very clear. I want to make quality videos, that is quality content, available to all the people. Okay, like when I was in college, I do not had access to internet, but today at least we are all having access to internet. But the thing is, you're not having enough motivation or enough quality content available to you. Okay, I can say quality content is available, but not in a single place. Okay, they are scattered everywhere. Okay, it will waste a lot of your time to get those quality contents. Okay, free, I'm saying free. Okay, so my aim here is, I want to code every day. I need a reason to code every day. For that reason I'm making this video, so that I can get a community, like I can have some peers who want to code and who want to learn. Okay, whatever I have learned, I want you to learn that. Okay, at least I can be your teacher for that. At the same time, since I have a reason to code now, I can also learn something more. Okay, that is my approach, that is my way of thinking. If you like this approach, if you at least you want a reason to code every day, you can come to our channel, see the videos. That will give you a motivation that okay, I have missed today's question, but it was a very nice question. You will get to know that, and that will provide you motivation to go hit that button in your computer, switch on your laptop, and start coding. Okay, that will be the motivation for you. Okay, that will be the starting point for you. So yeah, that was all for this video. Please subscribe to the channel. This really gives us a lot of motivation to continue further. We are about to reach 1.5k, so if you want, please subscribe. This will take us to 1.5k. So yeah, friends, that's all for today. See you tomorrow. Thanks a lot.